Ta-da. If I can get my windows to work how they're supposed to. All right, so yeah, now that we've done all this lovely workshop stuff, it's time to take a step back, relax for just a sec, and focus a little more on some lecture material. So now we've made a lot of mentions to kind of this whole dynamic of front end, back end, stack, all this voodoo magic terms that we kind of haven't explained yet. And so this is where I come in to, just take up the slack of everything else. The young infant, I get to cover all of this. Anyways, but so for the most part, we've been dealing with all of these front end type things that you get to see. Everybody cheers for them. It's like, oh, it's so beautiful. Your CSS is magical. These people on the back end, they don't get all the love they deserve. So for this lecture, we're kind of going to focus a little more on the unseen, the back end, the unsung heroes, the ones that keep your data safe and working. And but kind of before we can dive deep into what the back end is, we kind of got to talk about clients and servers because they're truly like the heart of our backend. So your client showing you your lovely front end, you're this lovely man here sitting here on your laptop with your Chromebook, and you're, let's say, doing some Google search. So here we have this actually wonderfully colored Google server room here. I'm kind of jealous. I'd like this whole color theme for my room. But so all of this data is sitting in these servers here, and you don't necessarily have to think of a server as these big rooms. In fact, actually later on, like even a day from now, I think tomorrow or something, we set up some basic server. Your server will be running on your own devices, because it's important to note that the server is just simply where the data and stuff for your site exists. And so you can sit here in Chrome, you can sit in Firefox, you can sit in Safari. For the love of God, do not sit in Internet Explorer. But the point is your client will make requests all over the globe for the data of your site. And that's kind of the whole background of how our internet client server dynamic works. Your client will make requests to your server, and your server will send back responses. That's the key heart concept that we're going to hit you with a brick repeatedly until you can chant it in your sleep. Clients do some lovely requests, and your servers do responses. So that's all that really happens when you type links and things into the address bar. So once again, clients, requests, servers, responses. We're just going to milk that as much as we can. And so, but we can go in a little more detail than just request and response. So how you specifically access information from servers on the other side of the planet, I can tell you it isn't through email or anything like that. You don't just email some Google dev, hey, give me site. No, we have specific types of requests and responses that you've seen pretty much all of your life, assuming you haven't lived under a rock. It's at the beginning of every, or just about every URL that you've probably typed in your life. This HTTP and HTTPS. So HTTP stands for Hypertext Transfer Protocol. You might notice that the hypertext is both a part of the HTTP and HTML acronyms because they're kind of sort of related here. They're both they're methods of transferring quickly the information that we need, hypertext. And HTTP will deliver these HTML files. And so you've been doing HTTP requests and responses. Your browser's been handling it for you this whole time. You just haven't quite known it. And so here is this whole magical, complicated thing that is an HTTP request in a single image. It's composed of a few distinct components. So your HTTP request will have its request URL, the specific site that you make your request to. In our case, it'll be catbook2021.herokuapp.com or something like that. And we'll cover each individual component of this a little more in depth in the next few slides, but you'll have your method, your headers, and your body kind of sort of optionally. And additionally, just as a side note, this isn't too important for the moment, but it will become very important later. There's the query part of the request URL that generally causes some confusion, but when we implement specific stuff, you can click this link, and I think it's one of Oxage's comments. I just picked a random one. But so the query bit is a part of some requests that allow you to query for specific things, including which comments, which stories, that type of deal. And so now we can cover the that second part of the HTTP block, the method. So there are, I think, a little over a dozen unique methods, but you'll only focus on like 4 or 5 of them at most. For the most part, you'll actually not go too much further than just these two. So a GET request is fairly self-explanatory. It gets data. A POST request will make data. A PUT request will modify some data, and delete, of course, deletes data. And as per usual, MDN is your friend and will list all of the HTTP methods that exist today. And so what about those other 2 chunks? So as stated before, the HTTP will request its method and its destination. The body can be used to give content. So when you wish to add a new content that will wish to add a new comment, you'll make a post request to the site, and you'll have to obviously provide the comment that you make, and that will be passed along in the request body. And the header can be used to do a little fancier stuff. I'll try and show a few examples of exactly what the header has, but it generally has a few extra details like authentication type things. If you're trying to access something that shouldn't be seen by normal people, it'll have what browser you're using. That way it knows how to give it back to you and whatnot. And so speaking of giving it back to you, now we've talked about requests. Now we can talk about responses. So responses are pretty similar to requests. One of the key differences here is that your response will have status codes. And status codes exist as 100 something, 200 something, 300 something, 400 something, 500 something. And they'll tell you how your request went. And you've probably seen at least a few different status codes. Somebody want to spam in chat We got one already. What status codes have you seen? 404, we got one of them. 403, that's another one. 5, okay, yeah, this is gonna get out of hand quick. So yeah, those are definitely all status codes that exist and are somewhat kind of common. So I like that 404 was the first one because 404 is the first one in my slides. So yeah, 404. Each of the status codes usually also have like a 2 or 3 word description after them. So generally when we say 404, we mean 404 not found. And so that just simply means that you make a GET request for a site that doesn't exist. The server will respond back to you saying, hey, that doesn't exist, and it will have, along with its response, a status code of 404 attached to it. Additionally, there are some good status codes. We got 200 OK. So this is the one you probably have seen most often in your life, but you never really realize it because your browser doesn't have to tell you things went okay because your site actually loaded. It doesn't have to tell you that things went okay. So you never actually generally see 200 OK plastered across your screen. No, you only ever see things when things go wrong. It's kind of like why back-end engineers are never appreciated. You only ever realize they exist when you're trying to hate on them for something that went wrong. Anyways, but we also have internal server errors. It's really hard to find these niche memes that are modernized. So enjoy like the 12-year-old pixelated memes I've thrown in throughout this. So icanhascheeseburger.com at the bottom left there. But and then we also have 400 bad requests with the pixel quality of 2008, even though that meme came out like 2017, 16, something like that, a Drake meme there. Anyways, but to kind of summarize the status codes, so 100 is informational, 200 is some sort of success status code, 300 is special status codes that I've summarized as like redirect, but it's difficult to 1 word, 2 words summarize exactly what the 300 status codes are. 400 status codes are something you did wrong, and 500 status codes are something the server did wrong. But for the most part, you only have to focus on the 200s, the 400s, and the 500s, as generally you won't ever see the 300s, and I don't even think I've ever seen a 100 status code. But they tell me it exists, so I have to tell you about it. And there are meme status codes. Twitter has a 420 status code, and somebody else has like a 409 My Little Teapot or something like that. Yeah, web developers are really funny. So you can see some of those status codes at the link I've thrown down below. Yes, that was sarcastic, Claire. Um, but uh, so all of these requests that you've been making, all of these status codes, all of this stuff has been out of sight, out of mind. So one thing I kind of want to do is bring it back into sight and bring it back into mind. So what I want everybody to kind of do is open up a page, maybe like Catbook. And what we can do is we can go to the lovely developer section using Control-Shift-I or Command-Shift-I, or hopefully you don't have a different shortcut than that. And there will be a network tab. I'll give an example in a sec. And if you refresh the page, you'll see all the requests that are made to load the site. Now, because I don't feel like exiting present and doing it myself, I just have a saved screenshot of me doing it with Catbook because I'm lazy. So you'll see there are requests for all of the comments. They have 304 status codes. I told you those wouldn't really happen all that often, but here's like 70 of them. Whoops, I lied. And so, Noah's G502 mouse needs to lock its scroll wheel. So, and then there's like a 200 down here for the favicon. There's a 200 for this iframe. You'll see that there are just a bunch of requests. If I scroll through this, if the Google slides thing, yeah, there were 101 requests that happened in a span of 1.13 seconds. That's kind of a lot there. And so we can actually make a couple of requests ourselves, and I will leave present for this. So here's a short request here that happens in 74 milliseconds. It's literally just to weblab.mit.edu/yeet. Sadly, we don't have a /yeet. I will fix that in due time. But this is what your browser will do for you automatically. You can see that there are some headers here. This is the response headers. As I said before, the response will look pretty identical to a request, just with things like status codes. So the header includes some information like the date, the server that replied to us, the exact length of the response, and the type of response. We can see that it sent us an HTML-based response. So you've probably seen this page at least once or twice in your life. But that's not the only request I got. I have another one. So I don't remember where I found this, but if anybody can read this, tell me what it says. So here's a request to some ASCII art page. And it's some giraffe ASCII art. I was too lazy to find some other request. That's a, you've been making these requests all these times, but they've just hidden from you all of this information that you never knew existed. And so before I go too much further, if you have too many questions, you can go to the questions doc, weblab.to/questions. There's also the queue, and there's also Zoom chat that I kind of sort of monitor. So if you want to spam me, you can. But I don't see too many Zoom chat questions, so I'm just going to continue along like normal. So I did kind of ignore one aspect of that last screenshot. You can see, if you look really closely, there are tiny blue lines that separate each of these requests, and they're also like on top of each other. Like, what happens? We're making all these 100 requests at the exact same time. How does that work in the code world? So as everybody's been saying, that's the async part of things. So almost everything up until now has been a synchronous type of code. If you've done a lot of coding before and it's not been web dev, it's probably been synchronous. And that essentially means that everything that you've called, gets executed, finishes, and then the next thing goes. So you can be relatively certain that if you call something, it will finish, do all it's trying to do before the next thing is called. And so it can't go on until the thing before it finishes. But that's not exactly too helpful for us in the web dev world. Sometimes we want things to be out of order and to be asynchronous. And so in the asynchronous world, we can't guarantee the order in which specific commands finish. So more concretely, why we want async. So you can see this little graph here is pretty similar in nature to this one. So rather than having them back to back, we can cram all of our load time into a much smaller package by having multiple things happen at the exact same time just we can't guarantee that it will happen in the order 1, 2, 3, 4 anymore. In fact, this one will happen 3, 2, 1, 4. But let's concretely attach stuff to it. Let's say 1 is some sort of request of some kind. 2 is a button press that then executes a color change, and then an array search happens. So in a synchronous world, your button press can't be registered, the color change can't happen, the array search can't happen until the request is finished first. In the asynchronous world, we can go ahead and let that request do whatever it's trying to do, but at the same time, we can go ahead and do our button press, we can do our color change, we can let the user do what the user wants to do while all that slow internet stuff happens in the background. And so we've talked on a high level what async is, but we haven't really said how we do async, at least on a concrete level. So here I have some function, get data, then call this, that just makes a get request. And before and after it, I have some more synchronous type things that just log A, B, and C. And so what I want you to do is place your bets on the exact order that these 4 things get called. Zoom chat, spam me now. What's your bet? Is it going to be the A, get request, B, C, ABC get, CB get A, or get ABCs? Come on, somebody spam me in Zoom chat. All right, I don't think I saw anybody get it wrong yet. So, yeah, so it's going to be the A, B, C get request, because the get request has to go to, I think this is German or Dutch or something, so this get request is going to that server that is somewhere in the middle of Eastern Europe there, and then it's coming all the way back, and obviously I think that's going to take just a little longer than console logging to my Chrome console. I think there's just a few more steps involved there. So naturally, because that's asynchronous, all this console logging is going to happen for us before. You can see it happens 9, 11, 12, 6. I didn't really write the code in order, it seems. But so we can see that it happens out of order there. And so, of course, I have yet another pixelated meme. But yeah, so asynchronous stuff doesn't happen in order once again. So we got 3, 2, 7, 4, 6, 1, 9, 10, 5, and 8. Funny 2016 Twitter developer meme. And so as yet another slight little aside, because we'll talk about them a little bit later, is promises. Promises are a specific implementation of, good luck sending it to anybody without being compressed, Emmy. So promises are a specific implementation of the of doing asynchronous type things. And so they exist to simplify the look of your async code and make error handling quite a bit simpler. You'll wonder how you ever lived without them. And I'm trying to be the best Billy Mays that I can be and sell you on this. So I'm not going to try and cover all the things that promises can do and the complicated things you can do with promises. But consider that thing I had you place your bets on earlier. So the way I would do that in promises type way is I would do this get request, and then I have a dot then. So this dot then is all that really exists to this basic promise. So we know that this GET request to memelink.com, I don't know what exactly exists there, but we know that the GET request to this site is going to take some time. So we're going to let it do its thing, and then kind of in a Pythonic way, we're going to say dot then. It reads exactly as you would say it in a sentence. We're going to get the stuff here, dot then, with the response, we're going to log the status code of the response. But promises, they have three states. We have a pending promise, a fulfilled promise, or a rejected promise. I think it would be a lot funnier if they wrote it as a broken promise, but web developers aren't that fun either, apparently. Once you either fulfill or reject your promise, it stays that way, and you can chain multiple promises together. So if I can append yet another dot then to the end of this dot then, and I can end up with a whole 60 long dot then chain. That would be terrible. Please don't do that. But you can. And so with the async stuff kind of out of the way, now we can talk about the first part of that lecture title of APIs and async. I should retitle this lecture. So the first bit of that, APIs, stands for Application Program Interfaces. So APIs are a set of endpoints. I will say what endpoints are in just a sec, that you can make requests to. So companies like Google, Amazon, and Facebook, they all provide these magical APIs, and they allow others to implement their services. So these specific endpoints, we're going to actually create these endpoints that I have at the bottom, I think on Friday. I have yet another lecture. You're not done with me yet. So if you hate me, well, you got to endure me for 2 more lectures. But when you go to a URL, you are making a request to an endpoint. So the endpoints that we'll implement later, one of them will be this /API/stories, which will accept GET requests. Then we'll have another one /story that accepts POST requests. But some endpoints can take multiple types of requests. And they do different things based on what type of request that they receive. So we'll have a endpoint /API/comment that either gets a specific comment if you send it a GET request, or it will create a comment for a specific story if you send it a POST request. And so I noticed in the Google Questions doc, like 3 or 4 of you asked about this Google Maps stuff and how we implement it ourselves. Well, ta-da, that's what I'm here for. So this random restaurant that I've never been to, but apparently exists in Boston, I don't imagine the web developer that worked on this restaurant site is an engineer for Google. I don't really think the guy is. But somehow this person has created a embedded Google Maps type thing. Now this person doesn't really have access to any Google servers directly. So how has this person accessed the vast Google Maps data? And well, in short, the answer is APIs. So the purpose of an API, you need to act. Sometimes we, as normal mortal human beings, wish to access the data of our corporate overlords like Facebook and Google. You yourself will eventually have an API. So it's not just limited to the corporate world, but that's all the cool APIs. So you need to access data, and you're not going to directly access data on servers. That's inconvenient and not really great for all the security people that work at Google. So the whole point of these APIs is that they provide these structured places, endpoints, that you can send requests to. And so now you can do a bunch of really cool things by simply asking the right people in a nice way. You can send them requests. And so yeah, visually, all of us, we sit here on this mortal client realm, and we interact with this API, and this API is the only one that can give us the data, or you can tell the API to put data in there. And so it just makes things much easier by having one singular middleman, this API. And so there are a butt ton of cool APIs that are a little underappreciated. So there's the Google Maps stuff I mentioned a moment ago. There's also the dog API. I discovered this one yesterday. I was happy about it. So the dog API, every time you do it, it's going to send back to you this response that will give you a dog, a lot of details about a dog. It also provides pictures of said dog too. So this is the dog that this API just told us about. We love dogs. We love dogs. It's great. So that's one lovely API, and you can see every time I make a request to it, it gives us a whole bunch of different ones. But there's also more technical, not quite so simple APIs. The people over at OpenAI have cool balls to the wall APIs that do magical things well beyond my mortal understanding, that do things like text generation, custom image generation, things that you, in your at least 2-3 week span here at WebLab, if you manage to do that, well, I'm sure the sponsors will absolutely love you and pay you lots of money. But I don't expect any of you to be making something of the scale that OpenAI has done over the past few years. So I'm not telling you not to try, though. That provides ways for you to access things that they've made in lots of cool ways. And so I've shown you these random shady links and things because we've been talking this whole time. This backend is this invisible entity that nobody ever really gets to see or is happy. No, a personal story. I did an internship for JB Hunt, and I was the VR team. They had an intern team for VR devs, and they, at the end of the internship, they go and show off the stuff they've worked on all summer, and the VR team woos all the higher ups, and it's like, woo, this VR thing is really cool, even though it's not really useless. I want you to tell me how many people are going to throw on a VR headset to track their package. Um, and so It's important to be appreciative of the API stuff. So I just wanted to share this particular API resource, swagger.io, which allows a visualization of your APIs a little bit. So they have a standard API here, but you can throw your own APIs into Swagger to kind of collect all of your API endpoints into something that is a bit more manageable, and it allows in-house testing of things. So if you wanted to, you can make post requests to your local thing. You can get test responses. It's more a debugging type thing that you can probably hit me up in office hours if you want to try and set up. I don't really expect too many of you to have complicated enough APIs to necessitate this scale of thing, but it is a good tool to keep in mind for the future in your lovely API development careers. And that's pretty much all I have to say about APIs and stuff. I do want to throw some more quick notes because you cannot forget about it. There is indeed milestone 0 due tonight at 11:59 p.m. EST. Please do not get confused about time zones like I did and show up to the Zoom lecture an hour early. And then somebody has a Zoom recording of you sitting in your chair in a blanket, unhappy about having to be up so early. So don't forget your milestone 0. Shouldn't take you too long. Do it pretty much right now if you haven't done it already. Don't forget that there's office hours from 7 to 9 p.m. EST. Again, tonight, I'll probably be there. There will be a few of the other staff there at least. And also one extra thing, because we only had like 6 responses yesterday, be sure to check out the daily recap Piazza post for the Google feedback form. It definitely helps us quite a lot in keeping track of if we're going too fast, did Noah rival Eminem and rap through this entire presentation, or was he slower than the sloth in Zootopia? That's kind of for you to decide. Please roast us in this feedback form. We won't be salty at all. It is anonymous, so roast us. The more feedback that you can possibly give, the better. Oh gosh, more Oxshaj and the Moon Pond stuff. You know, I can meet you in the Moon Pond too. But yeah, that's pretty much all I got for today. Does any other staff member have something to shout at me that I may or may not be forgetting? Speak now or forever hold your peace.
Should we all?
Well, for once, I think we've finished a little before our normal 5 o'clock time, so enjoy the extra 15 minutes to your nap before office hours. Is there a little homework tonight too? Checklist homework in React. Haha. Yeah, maybe also do that if you would like to get some extra React practice.
If anyone needs help like setting up stuff, I think staff will be here to hang around until like 5 if you need someone to help you debug. But yeah, other than that, y'all are free to go.
Thank you.
Hey, what is the checklist homework in React referring to?
We're going to share that in just a little bit. It'll basically be just another workshop, except it will be you doing it by yourself. So we'll provide some steps and give you some hints on how you can implement a checklist app in your browser.
Oh, okay, that makes sense. Thank you.
At staff, we should probably release the signups for milestone 1 slots sometime tonight, right?
We have to do it after milestone 0 is completed because we don't know how many teams we need to.
So
Count.
like 12:02.
Yes, 12:02. So we'll close the forum. Also, I saw someone here in the chat that got lost and wanted their team deleted. Can you make a private Piazza post and then Nick will probably handle that for you so you can join?
Yeah,
in.
probably.
Yeah, because I don't know how to do that. Yes, Derek, you just have to be ready for your presentations. You will screen share them with us, so it's not submitted anywhere.
Okay.
We'll release
thank
more
you.
information about that. Mhm.
Thank you.
Just in case Mr. Emmanuel does not make the thing yet, Nick, it's Emmanuel.